Hello students, welcome back. So in this session we are going to be covering string. String is an immutable sequence of character. Immutable means that these characters they cannot be changed. Once you define your string, those characters they cannot be changed inside a string. So let's see how we define a string, how we declare a string. Well actually I can declare my string using double quotes right here. So s equal to Python is easy to learn inside your double quotes. Okay, and then when I run this thing, it's gonna print my string right here. Okay, I'm printing my string and then I'm printing my type. I also want to see my type. Okay, it says print. It's a string. It's a class string. Okay, that's what the type is. I can also define my string using single quote, and single quote works too. So in this, as you can see, there's a single quote over here and single quote over here. When I run this, prints exactly the same thing. So it doesn't matter which one you use. You can use one or the other. Okay, so let's say I want to access elements of a string. So indexing, by the way, always starts with 0 in Python. So when I run this over here, it's going to print python. So here I'm trying to access the element of my string at index 0. So my index 0 would be p right here, okay? Here I'm trying to access the element at index 1. In this case, it's going to be y. And in this case, t is your index 2, h is your index 3, and so on and so forth. So as you can see, index 0, index 1, index 2, and index 4, I'm printing it out. It prints out the corresponding values over here. Okay, I can also access elements from the last, okay, the last element directly by using the negative index. So by saying s minus 1, it's going to print the last index, which is n over here. When I run this, it prints out n over here. If I say s minus 4, okay, it's going to print the fourth index from the end. So if you go over here, this is 1, 2, 3, 4. This one is your fourth index. So that prints out e over here. This is how it prints out e. Okay, so there's something called slicing. So in slicing, you actually this is how you do slicing. You use a square bracket. Your first argument is going to be start position colon end position colon step size. Now, if you do not give your start position, by default it is going to be 0. Same thing with your end position. If you do not give your end position, the default is going to be the last index. In other words, the length of your string. And your step size. If you don't give your step size, your default value is going to be 1. All right, so let's try to understand this thing through an example. Let's say this is my string. Python is easy to learn. So if I type s1 colon 8 colon 1, what I'm saying that my start position is 1. Okay, my start position is 1 and my end position is at index 8. Okay, index 8, and my step size is 1. Step size means how much is going to increment. Okay, so when I run this thing, it's gonna give me a YTHON space IN. What's this happening is this. It's starting with index 1, which is my Y. So it prints out Y right there, okay? Then it's gonna keep going up till index 8. So index 8 is at 6, S over here. So this S character right here, let me just come over here. Rest, as I hope you're able to see, this S is my index 8. So it does not print index 8. Be aware of that. Python and in list and tuples and all those things. So when you try to access elements in a slice, it's always going to be one before the last index. So in this case, if you write 8 over here, it's going to be up to 7. So it's going to print YTHON space I. I is your seventh index. Okay, one in this case is a step size, basically saying that increment by one, increment by one. That's what your one is. Okay, so let's look at this statement right here. What's happening over here? So I'm going from index 1 to index 8, and my step size is 2 now. Okay, over here, my step size is 2. So essentially, what's going on is this that let me just show you. So it starts with index 1. So this is my y, right? So this prints out y, and then it goes 2 steps. So it's going to skip th. Okay, it's going to skip t, it's going to move to h right here. Okay, then it's going to print h. Okay, then it's going to skip o, it's going to go to n right here. It's going to print n. As you can see, it's printing y h n. Then it's going to skip blank space and it's going to print I, and then it's not going to go any further because then it's going to reach the end of the string 8. Okay, and so it's going to print y h n I, and that's how you come with this y h n I. Okay, so let's see. So you can actually change this index. Maybe you could do 2, 3, and play around, so you'll get a hang of it. This one right here is basically from index 1 to index 3. Okay, so let me just comment these two out. All right, so in this case, when I run this, it's going to print from index 1 to index 3. So index 1 is my y, and index 3 would be, actually index 3 would be h, but I'm actually writing 4 over here, 4, right? So it's not going to print the 4, it's going to print 1 before the 4. So 1, 2, 3. And as you can see, it's printing index 1, index 2, index 3. Okay, what about the next one? This one over here, I'm printing starting from index 2 all the way up to 13, and step size is my 3 in this case. So if I run this, it's going to print these elements T and SA. So your T starts from here, okay, then it's going to go, remember step size is 3. So your 3, let me just use my pen. So come back over here again. So it starts with T, right? So it prints out T, then it's going to go step size 3. So 1, 2, 3, then N. N, as you can see, T, N, and then again 3. So 1, 2, 3. So in this case, S right here. S, okay. Then it's going to go again 3, right? So it's going to be S, 1, 2, 3. A, A. And then it's not going to go after that anymore further because then it's going to reach the limit, 13. 13th is your final index. It cannot cross the 13th index. All right. So this is how you can print, these slices. Okay. Then you can also print, let's say you want to print the first 11 characters. So you can just say S square bracket colon 11. Since you're not specifying this position by default, your start position is going to be 0. In other words, from the beginning. So when I run this, it's going to print the first 11 characters. Python is an up to E right here. But remember, it does not print the 11th character. It's going to print up to 10th character. Okay, it's going to, sorry, up to the index 10. So just be aware of this thing. This is going to print up to index 10, not the index 11. What about this right here? Here I'm saying that to print from index 8, okay, start with index 8 all the way up to the end. So since I'm not specifying this position, end position, by default, end position is going to be the last index. Okay, so that's what's happening over here. So when I run this, it's going to print starting from index 8, it's going to print all the way up to the end right here. Okay. All right, then there's a string concatenation. So let's say you have a string, Python is easy to learn, and you have another new string. Okay, new string is S plus is and is fun. So what's going to happen? What this plus is doing is going to take the old string, which is this right here. Okay, my S, and it's going to combine this plus. In this case, is going to combine with this right here. So when I run this, it's going to print Python is easy to learn, and then it's going to combine with this part and is fun right here. So this is called a string concatenation. Then maybe you want to check for a substring. So let's say Python is easy to learn and you want to check if the word th is present in s. You can do that too using in operator. Okay, so in this case, when I run this, it's going to print true because th is present in there. You can see th right there. Now, how about rain? Is rain present inside? Well, the answer is no because you don't see any rain. So this is going to return false. So when I print my b, in this case, it returns false over here. Let's explore some of the string methods. So let's say this is my string. Python is a cool language. Now look at this thing. My O is capital in this case. Okay. All right. So if I want to make everything lower, I can use s dot lower. Let me comment everything out. Okay, if I want to make everything lower, I use s dot lower. I run this, it's gonna print Python is a cool language. As you can see, everything has become lowercase. Even this O right there, it has turned into lower O case. Okay, what if I want to make everything uppercase? I can do that too. I can do s dot upper. Now if I run this, it's gonna print Python is a cool language right here. Okay, everything has turned into uppercase. Well, maybe you want to replace, okay, maybe you want to replace your py with my, okay. So this py you want to replace with my, you can do that too using this inbuilt method called replace. And in this case, as you can see, your py has been replaced with my. Okay, maybe you want to find index for is. There is a string called substring called is somewhere inside, and you want to find the index of that. So there is an inbuilt method called find that's going to return the index of that. In this case, the index is 7 right there. It's telling you. So the index for is 7. You can count as a matter of fact. So this is your 0, 1, 2, 3, 4, 5, 6, 7 right there. Seventh index. Okay. Sorry, index number 7. So that's why it prints out 7 right here. Okay, then what if you want to count? Maybe you want to count how many O's are there. So this is my O. When I run this thing, it's going to print 2. It says there is only, oops, sorry, there's only 2 O's. And actually, it's going to count this O right here, Python, and that's part of the Python, and this small O because it's case sensitive. What if you want to count all the O's, including the capital ones? Well, one thing you can do is you can use a little chain. So what I'm doing, I'm taking my S, converting it to lowercase, and then I'm counting my O. Now when I run this, it's going to count my 3 O's, okay? Because it just took the whole string and it converted into lowercase, and then your O all became lowercase, then it counted as 3 over here. Okay, you can also find you can also remove some empty spaces. So a lot of time you come across this string where there are some empty spaces in the beginning and empty space at the end. As you can see, there is some over here. So there's something called else strip. Else strip is going to remove this empty space from the left hand side. That's what your else stands for. So let me just comment these two lines out and run this. And there you go. So in this case, it actually removed the empty space from your left hand side, which is this right here. Okay, those empty spaces are gone. Okay, how about right one? Well, what if you want to remove your, oh, by the way, you can verify that too. You can actually type the length, you can just say len, right? You can calculate the length of this. That will give you, know, if the space has been removed or not. You can verify that. As you can see, it's saying 15. The actual length of this is 17. I counted. You can count too. And since I removed the empty space from the left, these ones, so now you got 15 characters over here. Okay, what if you want to remove from the right? You can do that too. So there is a R strip in this case. As you can see, it removed this one right here. Okay, so if I move my mouse and if I cursor over there, you can see it's not going anymore further. It's not selecting anymore. Over here, you see selecting. Now, what about this right here? If I go this way, you can see it selects it right here. Okay, so this way you can remove left and right string. What if you want to remove both the empty spaces from left and right? So there is a s.strip method that's going to remove empty space both from the left and right. In this case, again, if you type length, you can calculate the length of this just to be sure. It has removed the length, removed the empty spaces. When you run this, you can see 14 because these two, and this one is gone. So 17 minus 3 is 14. Okay. All right. So this way you can remove empty spaces from the beginning, from the from the left, from the right, and both left and right together. So let's say you want to capitalize everything. So what capital this inbuilt function what capitalize does, it converts the first character to uppercase. Okay, this is important, and the rest to lowercase. So if I run this, you can see it converted just the first character to uppercase and everything became lowercase. You see this is OL was capital, it turned into smaller case. P is small, it turned into uppercase. So this is called capitalize. Look at this title. What title does is gonna every single word, okay, the first letter of every single word is gonna make it capital. You see, P is capital, I is capital, C is capital, L is capital, H is capital, everything is gonna get capital. Rest of the words, they're gonna be rest of the characters in the word, they'll become lowercase. As you can see over here, your OOL, everything has turned lowercase right here. Okay. Then there is a inbuilt method called ends with, very helpful. So let's say you have a text example.csv, and you want to check does this file ends with .csv. Sometimes you have a file name and maybe you want to check if it's a CSV file, Excel file, text file, what type of file with it is it. So you can use this little ends with the inbuilt method. So in this case, it prints true because it does end with CSV. What if I type CST maybe? Instead of just I'm just picking up some numbers, CST. As you type, it's going to print false because CST does not exist. All right, go back to CSV, run this, and great. Now this another inbuilt method called partition, very helpful. So this actually what it does is splits your string at the first occurrence of your separator into a three tuple. So it's going to be before, sep, and after. This will be a three tuple. So let's say this is your text, right? Email@example.com, and you call text.inbuilt function partition, and you specify your separator. My separator is at the rate of. So what it's going to do is, let me just run this. So you'll see it's going to print a three tuple. It's going to print your character before the separator, email, okay. Then it's going to print the separator, separator right here, and then it's going to print the character after the separator and after the separator. What if I do this thing instead of saying separator, I just put E? If I put E, it's going to print this whole thing first, then it's going to put dot, and then it's going to print com. So let me run this, and as you can see, it prints the whole thing first. Okay, this is my first character right here before the partition. Then it printed the separator. Then it printed the element after the partition. This right here. Okay, then you have sometimes you have to split a data by delimiter or separators. You can do that too. So let's say there's a message given to me like this, okay, and you can actually split this. There's an inbuilt method called split. You specify your separator. It's going to take the string and it's going to split this based on that separator right here, and it's going to convert that into, actually it's going to return a list over here. So in this case, I'm taking this message right here, I'm splitting based on the comma, and as you can see, it splitted this whole string into a sequence of into different characters, and into a list, actually a list of characters. So 2025 08 23, right, that's your first one. Then there is a comma, okay, split over there. Then it's a ash, then there's a comma, and 34, comma, 00, and so on and so forth. Well, you can also split based on a semicolon. Doesn't have to be comma, because sometimes your data, okay, may contain a comma in it. For example, this, maybe it means the user meant 34,000, okay? So you know how we write 34,000, we put 34 comma 1000. So maybe that's what the user means. So over here you can use semicolon. So I'm splitting based on the semicolon, and as you can see, it prints out exactly same thing, except now this 34,000, the comma is going to be part of that. Okay, it's not going to split based on the comma. Okay, you cannot add numeric types to strings. So for example, let's say my a equal to 7 is a string and my b equal to 5. If I do result equal to a plus b, it's going to give me an error, okay, because this is a string and this is an integer. You cannot add a string to an integer. Wrong. Okay, all right. How about multiplying a string by a number? What do you think? Well, the answer is yes, you can. So let's say this is my string 773 and my b equal to 5. If I say result equal to a times b, what's going to happen? It's going to give you string repetition. So when I run this, you're going to see 773 repeated 5 times. So 773, 7732, 7733, 4, 5, 5 times over here. Okay. So this way, one of the interesting application of this would be data. So let's say you can create some data. Let's say you type Jerry, okay, is happy. Okay, and then yeah, happy, and then that's it. Then you can actually print this Jerry is happy. Like you see, it just generated data right there. You can make it like 50 maybe. Hit 50, and now it generated Jerry is happy. So you can generate some fake data for some testing purposes really quick like this. Okay, now string is immutable. So just want to show you that, remember in the beginning I said string is immutable. So let's verify that. So let's say this is my string republic. I want to change one of the characters. Let's say I want to change the 0, the element at index 0, or I want to change to z. And when I try to do that, I get this message: string object does not support item assignment. So in other words, you cannot change the elements of a string. Once you define it, it stays like that. This is called immutable. Thank you, students.